In this video, we're going to talk about exercises from 2.5. Topic is completing the square. Completing the square is how we're going to find the vertex form of a parabola and turn an equation that looks like f of x equals ax squared plus bx plus c into a formula that looks like a times x minus h squared plus k, where our vertex is going to be at hk. H is going to be our horizontal shift for our function. K is going to be our vertical shift. See our video last time that has to do with transformations of functions in the library of functions 2.4. Going to be putting that to specific use here with the function y is equal to x squared. That kind of answers the question of how this is going to help us graph quadratic functions. It's going to help us be able to do those use that transformation method. So if after completing the square in number 2, we get f of x is equal to x minus 2 squared plus 3, is x equals 2 considered a root? No, it's not a root because it's not going to be a 0. It's not equal to 0, but it is the x coordinate of the vertex. The x coordinate of the vertex is 2, and the y coordinate of the vertex is 3. But 2 is not a root because it's not a 0 of the function. Okay. One of the variations of completing the square gives you the form cx plus a quantity squared plus b. In this case, does c represent a vertical stretch strength or horizontal stretch strength of the function? It would be a horizontal because it's inside here with x, so it's very easy to change that up to write it so that you can see the vertical stretch shrink on x. So if we pull c out, it's c squared x plus a over c, like that, plus b. You can see that c had something to do with the horizontal here because it's still in there with x, but you have a vertical stretch of c squared here. So what we would do here to find what c is doing is we would set the inside equal to 0. And that's going to be how I'm going to shift horizontally so that I can find my new vertex. It's going to be at negative a over c. All right. After completing the square, you get that g of t is equal to t plus 2 squared minus 6. What are the values of a and b if your goal form is x plus a squared plus b? So I don't like that form because a and b are not telling you anything about the vertex that way, but a is 2 and b is negative 6 according to that form because they're keeping the signs the same there. My form that I am going to be using throughout this video is a times x minus h squared plus k. That's always what I'm trying to get to when I complete the square because I want to get it in vertex form of the parabola. So I'm going to ignore the instructions here for this, and I'm going to complete the square according to the method that we need to use to get the vertex form of the parabola. So f of x is equal to x squared minus 4x plus 6. If the leading coefficient is not 1, factor out the leading coefficient from the x squared and the x terms. We'll get to one of those. We'll get to those over here in the next section. But all of these leading coefficients are 1, so I'm not going to have to worry about that. Separate the constant off. Just hold it off to the side. Take half of the middle number and square it. Where I added it in here over here, I'm going to subtract it over there so that I just added 0. That makes a perfect square trinomial here. And my vertex is going to be what makes this 0 is going to be 2. And then when that's 0, 0 plus 2 is 2 is my y coordinate. This is h, this is k. It's always x minus h squared plus k. So there we go. I found h and k that make this true, and that's going to give me the vertex of the parabola. 6. G x equals x squared plus 20x plus 40. We're going to take half of the middle number and square it. We're going to subtract that same number so that we get x plus 10 squared minus 60. My vertex is going to be at -10, -60. -10 is what makes the parentheses 0. This is very important that you know how to do this because it's going to be necessary in calculus for many of the forms that we're going to study later. It's also important to know for equations of circles, equations of parabolas, hyperbolas, ellipses, all kinds of things like that, all kinds of conic sections. Again, we're going to take half of the middle number and square it. We add 16, we're going to subtract 16, so we did nothing. This is x minus 4 squared minus 11, so my vertex is at 4, -11. We've got x squared minus 22x minus 4. They're being nice and giving me even numbers for most of my middle terms. They're going to stop doing that in a second here. So 11 squared is 121. Minus 121 is going to be x minus 11 squared minus 125. My vertex is at 11, -125. 9. X squared minus 6x minus 2. Half of the middle number squared. Going to give me 9. It's going to give me x minus 3 squared minus 11. My vertex is at 3, -11. Number 10. P of x is equal to x squared plus 11x plus 4. Okay, this one's going to be different because it's not an even number in the middle anymore. So when I take half of the middle number and square it, I'm going to get 121 over 4. I need to multiply by 4 over 4 here. It's going to give me x plus 11 halves squared plus 16 minus 121 over 4. X plus 11 halves squared plus 105 negative. So 105 over 4. Let's just check that out, make sure. Yes, that's right. So my vertex is at -11 halves, -105 over 4. Number 11, P of x is equal to x squared plus 13x. So we're going to add 169 over 4 and subtract 169 over 4. This is x plus 13 halves squared minus 169 over 4. My vertex is at -13 halves, -169 over 4. Number 12. going to, again, write this, but we're going to have to take the c out front here. So 9x squared minus 12x plus 12. I'm going to factor 9 out front first. 12 divided by 9 is going to be 4/3. Keep the plus 12 written out there as the constant. Now I'm going to take half of the middle number and square it. When I take half of the middle number, that gives me -2/3. When I square that, that's going to be 4/9. I just added 4 into the problem when I multiply 9 times 4/9. So I'm going to subtract 4. That makes this 9 times x minus 2/3 squared plus 8. My vertex is going to be at 2/3, 8. X squared minus 2x plus 2. Take half of the middle number and square it is going to give me 1. 2 can be split up into 1 plus 1. This is x minus 1 squared plus 1, and my vertex is at 1, 1. 14. 4x squared minus 4x minus 4 is going to be 4 times x squared minus x minus 4. Half of my middle number squared is 1/4. 4 times 1/4 is 1, so I need to subtract 1. 4x minus 1/2 quantity squared minus 5. My vertex is at 1/2, -5. 15. 4x squared plus 4x plus 6. 4 times x squared plus x plus 6. Half of my middle number squared is going to be 1/4. I added 1, so I'm going to subtract 1. 4 times x plus 1/2 squared plus 5, and my vertex is at -1/2, +5. 16. 9x squared plus 18x plus 4. 9 comes out. Half of my middle number squared. And I'm going to subtract off 9 times 1. So this gives me 9 times x plus 1 squared minus 5. And my vertex is at -1, -5. Now we're going to complete the square and graph the function. So when we complete the square, this is going to be t squared plus 2t plus 1 plus the junk of 2 over there is t plus 1 quantity squared plus 2. My vertex is going to be at -1, 2. -1, 2 is my vertex. My y-intercept is at 3. Symmetry tells me that there's going to be 1 to the left is also going to be 3. My axis of symmetry is right down here, down the middle. So there we go. As long as my vertex is not my y-intercept can give me another point that I can use symmetry with. Q squared minus 2/3 q. And take half of it and square it is going to give me 1/9 minus 1/9. Give me q minus 1/3 squared minus 1/9. My vertex is at 1/3, -1/9. So 1/3 -1/9 is somewhere right here. And we had that it was going through 0, 0. So it's going to go through the same point reflected over here. And there we go. It's like that. X squared plus 4x plus 2. Half of the middle number squared is going to be 4. So I need to add to make this 4 minus 2. X plus 2 squared minus 2. My vertex is at -2, -2. It's opening up. It doesn't stretch or shrink at all. It's got a y-intercept of 2. So when I come 1 to the right, come 1 up. When I come 1 to the left, I come 1 up. 2 to the right, I go 4 up. 2 to the left, I also go 4 up. Like that. And I have one more in this section. X squared minus 4x plus 6. Half of my middle number squared is 4. This is 4 and another 2. Makes this x minus 2 quantity squared plus 2. Gives me a vertex of 2, 2. It also opens up without any stretch or shrink. I'm going to go 1 left, 1 up, 1 right, 1 up, 2 left, 4 up. It's going to give me 3, 4, 5, 6. 2 right, 4 up. It's going to give me also 6. And there it is. None of these stretched or compressed the graph, so they all should have the same shape as the original y equals x squared. Now, we want f of x is equal to x minus 1 squared minus 2, and they want us to expand this. So this is going to be x squared minus 2x plus 1 minus 2. Again, give me x squared minus 2x minus 1. And say, uh-oh, that would be a problem, right? That's okay. They want us to graph it anyways. We've got a y-intercept now of -1. We have a vertex at 1, -2. So it's opening up. So we have another 1 to the right is going to give me the same thing here. I'm not going to be able to calculate what my x-intercepts are easily by factoring because they're irrational, but I can find them by the quadratic formula that x equals -b plus or minus the square root of b squared minus 4ac all over 2a. It's going to give me x equals 1 plus or minus the square root of 5 over 2. And this is going to be a little bit bigger than 2. This is going to be a little bit less than -1 over here. So there we go. That is it. There's really no reason to expand this most of the time unless it helps you factor the problem and see what the x-intercepts are. So maybe that's going to happen once or twice here. I doubt it. It's just going to help us see what the problem started off as. So that is, that's one that be able to factor. That's good. So my y-intercept here was -5. My vertex is at -3, 4. And my y-intercepts are at, or my x-intercepts are at -1 and -5. And there we are. H of x is a -x plus 3 squared plus 4. This is exactly the same thing as -1 x minus 3 squared plus 4. -1 squared is 1. So that's the same thing. Let's expand it. There are no factors of 13 that are going to give me a sum of -6, but 13 is going to be my y-intercept. So 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13. It's going to open up. It has its regular shape, where if I go 1 right, I go 1 up. 1 left, I go 1 up. 2 right, I go 4 up. 2 left, I go 4 up, and so on. So it's the shape of y equals x squared. It just got shifted all the way up here. Oops. That is not quite right. Vertex is at 3, 4. So 3, 4 there. There's my vertex. So and it opens up. So I'm sorry, it opens like this. And then if I go another 3 to the right, it's going to come up here like this too. And there we go. That's what it looks like. So, all right. One last problem here. Y plus 2 squared minus 1. Y squared plus 4y plus 4. Minus 1 is y squared plus 4y plus 3. That breaks down into y plus 1 and y plus 3. That helps me get some x-intercepts. I also have a y-intercept of 3. We have -1. We have -3. Our vertex is at -2, -1. And there we go. That, I believe, is everything for this section and for this chapter. So next time when we come back and talk about chapter 3 stuff, we'll be talking about solving trigonometric functions and some of the other more calculus-y things that we're going to do in pre-calculus that are going to be things like partial fraction decomposition and those sorts of things. All right. Have a good time. See you for the next video.